Hello everybody, welcome back to another edition of the Modicon M221. I'm your host Leandro Mada, and in this video we're gonna talk about the PWM feature that we have on the controller. So let's go to the presentation. So PWM stands for Pulse Width Modulation, okay? And in the software we're gonna have this icon over here in order to add the functionality or the function block in our code. So let's go to the next slide. Okay, so basically the PWM allows us to convert an analog signal in pulses. Okay, so depend on the value that we have on this function block that we're going to see, okay, but we're going to have a sequence of pulses, okay, and the difference on the pulses that we're going to see will depend on the status of the pulse between 0 and 1, okay, and the duration on each cycle. So basically, as it says over here, the period of the pulses is fixed, okay, so we have a fixed period, okay, but what is different is the transition in, or the status of each pulse, okay. The part of the pulse that is in true, okay, that is what we're gonna change on the software. So basically there are two parameters that we need to identify here, which is the period of the pulses, okay, and then the duty cycle, which is the part on the cycle that the output is going to be in true, in 1, okay. So continue with this. The best way to check this is with this graphic, okay. So so imagine this graphic that you can see over here, okay, where the analog value, okay, can go from 0 to 100, okay. So if the value is 0, as you can see here, the pulse will be in 0, okay. We're going to see a 0 on the output. When the value in this case is 20, okay, so in this case it means that we're going to have in the output the 20% of the period. The duty cycle will be the 20%, okay. That's basically the idea. So we're going to convert the analog value in pulses based on this analog value, and this analog value will be linked to the duty cycle, okay. So it's important that in the analog value that we're going to use in our block, the range goes through 0 to 100, okay. So in that case we can limit the amount of the duty cycle that we're going to use on the PWM. So basically we're going to have a sequence of pulses in one of the output that we're going to see, okay, based on the value of the duty cycle that we define on the block. We're going to cover that in details. So as you can see over here, I have two periods, okay. So in the first period, when it starts, the value is 20. So if we divide the period in 5 parts, okay, only the 20% of this period is going to be in true, okay. On the next period, when the function block reads the value, okay, is 20%, and then the 20% of the period is going to be in true. Then in this case I have the 60%, okay, the value 60 for the function block for the duty cycle, okay. So if we divide the period again in 5, okay, you can see that the 60% of the period is going to be in true, and the other 40% is going to be in 0. You can see here again I have started another period, 60%, then 0. And in this case I have the 80%. So if we divide the pulse, the period in 5 parts, okay, only the 80% is going to be in true. So this is basically the idea how it works in the M221, okay, the function block. So on the function that we're going to have, we need to configure the duty cycle, okay. Then in another part of the configuration we can define this period, okay. We're going to cover that also. So the important thing that we need to know is about the relation between frequency and period, okay. You can see here this is the period, okay, and if you use this formula, okay, frequency is equal to the inverse of the period, okay. So we need to check in our PLC, okay, the range for this frequency. Okay, so in order to use these digital outputs, what we need, there are special outputs in our PLC in order to use it. We cannot use this in a relay, otherwise it's going to be damaged. Okay, so in the PLC, in the M221, we have some PLCs in the range, okay, in the M221 range, that allowed us to use this PWM feature. Then they are the ones that has the letter T for tango at the end. That means for transistor output. Okay, so in all these kind of PLCs, okay, where we have two digital outputs dedicated for this PWM pulse width modulation, we have the outputs Q0.0 and Q0.1 for this task. Okay, and the range that we have for this period, okay, can go from 100 milliseconds to 1 second, okay, which is this part. And then in this part, what we can configure is this duty cycle, which is the part on the period that the signal will be in true. Okay, so that is the idea. So if I already mentioned that the range is this one for 100 milliseconds, yeah, 100 milliseconds. Yes. No, sorry. It's gonna be 0.1 milliseconds. Okay. It should be 100 nanoseconds. Okay. To 1 second. If we use this formula, we can see the range of the frequency. Okay. So if we use this one, 1 second, the minimum frequency will be for 1 hertz, okay, and then on this one 0.1 milliseconds, okay, should be, if this is the formula, it could be this 10 kilohertz, okay, the maximum frequency, okay, that it will be related to the period of the signal. So if we continue with this, it's time in order to know how we can program this. So if we go to the configuration part of our controller or the software, we need to go to the pulse configuration. So let me just show you something. Let me just open this, apply. So in this case, I have this one that ends with the letter R at the end by relay. As you can see over here, I don't have anything to configure the output for the PWM. So we need to use the one that ends in the letter T. Okay, if you drop this one, you can see they have the pulse configuration, and if I use this one, I do have. So it's mandatory to use the one with the letter T for transistor, otherwise check also the manual and see if it works or not. Okay, drag and drop, you can see that you have it. Okay, so once you have configured that, okay, or you have added into your system the PLC with the letter T for transistor at the end, okay, you can see the pulse configuration. And the pulse configuration generator, you can see over here that you have 2 instances for different stuff. So let's continue with the presentation. Okay, we just need to click in these icons over here, the square with the 3 points. Okay, and these are the options that we have. So in this case, I'm only going to focus on the PWM. Okay, for the PTO and the frequency generator and the PLS, I'm gonna cover that later. Okay, I believe it's more important this one of PWM here. So I'm going to do this. So here you can see that you're gonna see this window, okay, with no configuration. Okay, so we need to select one. When you click over here, you must see the different configuration that we have for the digital output. Okay, so I'm going to select PWM. Once you select this, okay, depending on the instance, the PWM feature will be linked directly to one of the outputs. Okay, so if we go back to the software over here, configure PWM, you can see over here Q0, and if I link this one, Q0.1. okay, so that is the idea. So once you have configured that, okay, there are two things that we need to check here, which is the time base and the preset. Okay, this time base and preset, okay, will help us to define this value, the period. Okay, so we need to check that, and depend on the range, this time base, we have limitation on the amount of the preset that we are able to put over here. So if we select time base 1 second, okay, the preset value is gonna be, must be 1, okay, because we have the limitation that goes from 1 Hertz to 10 kilohertz. Okay, we cannot use something else over here. So if we go over here and select PWM 1 second, I'm trying to do something like that. Okay, error 12 2, we have an error. Okay, it would be different if I select a different time base. Okay, that's something that you need to check. Okay, so depends on this value, the time base, the preset have different ranges. So time base 1, the only value that we have is 1. If it's 10 milliseconds, the time base, we have between 1 and 100, 1 millisecond, 1 and 1000, and 0.1, 1 to 10,000. So this will be linked to the hertz limitation that we have on the controller. Okay, that is the main reason over here. Okay, so this is something important that we must check at the time when we select the time base, so we are in the range where we can change on the software the preset in case we need it. So if we continue with this, now it's time to add the function block for the PWM. So this part is simple. We just need to go to the programming, select the function block, and add this icon in our program. So over here, I'm going to configure this one. Apply, programming, here are the function blocks, here pulse with modulation. Okay, so remember to use this one, between this one, the pulses, and this message, this one. Click and select. So then we have another thing that we can do. So we can add a contact over here. So the contact would enable the use of the PWM. Okay, but let's continue with the presentation. So once you add it in your code, okay, you can see that you have the possibility to change the preset. But if it's in 1 second, this is gonna be only 1. Now, you can see over here the in, okay, is the enable of the PWM. So if we want to enable the PWM, this input must be in true. If we continue with this, okay, if we double click on the PWM, we should be able to enter into the pulse generator properties, and here we should be able to change the symbol, okay, from empty to something that we want, and also add the comments. I don't remember it, probably we can change the time base. Let me just double check. I don't remember it. Double click. Now the time base must be changed over here. Okay, pulse generator. This is where you can change the time base. Okay, you cannot change it by software or in the properties. Okay, what you can change on the software is the preset. Okay, that we're gonna cover that in a few seconds. So here we should be able to change the symbol if in case we want it. So we go over here, I can say PWM digital Q0, PWM, okay, PWM digital output 0. Apply, and you can see over here there's some information. Okay, it's just the name of the instance. So if we continue with the presentation now, okay, we can add contact over here, okay, in order to activate the use of the PWM. Okay, in this case I add this one. Okay, let's add it. So I'm going to use M0, double click over here, CMD, enable PWM, enable. You can add some comments, comment, enable PWM. There we go, you have it. So if we continue with this, okay. Now, in order to change the preset value, okay, which should be the time base, okay. No, sorry, no, this is not the R, okay. In this case, sorry for that. So I was thinking something ahead. So we have configured the time base, okay. So we have configured the time base and the present. That will be the period of the sequence of pulses that we're gonna have, okay. What we need to do now is to configure the duty cycle, which is the amount of time that I want that the signals goes through, which is this one over here. You can see is this. We have already configured this part, okay, this period, okay. What is important now is to define which should be the duty cycle, which is this part, okay. Let me just grab the pen. It should be this part. This part over here, okay, will be the duty cycle, and the duty cycle will be related to these values that we have over here, okay, which is the duty cycle, the part that our signal is going to be in through. As you can see over here, this one is the 20%, this part is the 60%, okay, and you can see this part is this part, the 20, this part is this one, okay. So that is the idea over here. So let me just perfect, so we can continue. Okay, so don't want this laser. There we go. So in order to change now the duty cycle, okay, we need to access into the instance of the PWM that we have, then .r, as you can see over here. This .r allow me to change the duty cycle. So we can use a variable, okay, in order to change this. So if we go to the software, okay, you can use, for example, this, and use the PWM underscore DQ0.R to point equal a percentage NW variable, okay. I use the name of the instance that you can see over here, which is this, or you can use the address percentage PWM 0.R, okay. It's the same. Here you can use something to set the value, or you can use an analog input and then make some kind of scaling to limit this value to 0 to 100, okay. That's going to be the duty cycle. So this one will be the duty cycle. Duty cycle, the duty cycle of our signal, okay. So if we go back to here to the presentation, okay, so this would be the amount of information that you need to configure, or you need to use in order to configure the PWM in the M221. What I was thinking, okay, and I got confused, is that you can also access into the preset, okay. So here is how you can change the duty cycle, but do you also have the possibility to change the period, okay, that you have configured in the software. In order to do that, okay, we just need to go over here. Instead of using .r, okay, for duty cycle, we just need to use the P for preset, okay, this value. So this TB is fixed, okay, but these ones can be changed on the software, okay. So if we go back over here, preset. You can use the short or just leave it over here. Okay, here we can use percentage PWM 0.p, and here we can assign another variable, MWM 10. Okay, so in this case you can change this preset value. Okay, and depend, that's something that you need to know, depend on the time base that you have select. Also you have a limitation on the value that you have. Okay, so if you select the higher value, you can see on the preset, there will be the lower frequency, okay, because it's inverse. Okay, so if you select the 1, you always have the highest frequency. Okay, you can see depend on the time base. Okay, so this is how you the practice part for you. To just create a new project I have done, select the M221 with the transistor output, configure one of the digital outputs, the 0 or the 1, it doesn't matter. Then you need to check which is the digital output that you're going to use. Then you need to add the function block as I already mentioned, then configure the variables, and then download and see what's going on. Okay, I don't have right now with me the M221 with transistor output, so in the next video with the presentation, when I have the M221 with transistor, what I'm going to do is to show you how you can link another input or another variable that doesn't came in 0 to 100. Okay, so what we need to do is to escalate that to have the 0 to 100 value, and that value is going to control the PWM that we have using the duty cycle. Another thing that you can use is to, for example, use PID. Okay, the value of the PID usually goes from 0 to 100, so you can use that for the PWM, and then use digital output. Okay, so this is it for the PWM on the M221, just an introduction how to configure. As you saw, it's very simple. So this is basically everything on the PWM, doesn't have any mystery over here. So thank you very much for watching me, and I see you on the next one.